This week, Hal Pomeranz from Deer Run Associates will join us to discuss practical advice for protecting the Linux software supply chain. In the security news, VMware and ransomware makes you want to run somewhere. Double free your OpenSSH. Download the right software. You have Docker and I have root. We don't talk about cores. To vulnerability or not to vulnerability. Vulnerability risk scoring, a matter of perspective. A very persistent Cisco attack. Running UPnP without all the protections. Overflowing a buffer in your bootloader over HTTP. C can be memory safe, but developers will still screw it up. And lasers, microwave satellites in the sun. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly.
Right now, everybody is talking about cryptocurrency, and the cyber criminals are hiding in the conversation. Cyber criminals use social engineering loaded with urgency and fear to successfully prey on your company, your employees, and your customers. Spear phishing is just one of 13 types of email threats. Barracuda has identified these 13 types and shows you how you can protect your company, your customers, and your reputation. Find out about the 13 email threat types and Barracuda email protection. Get your free ebook at securityweekly.com/Barracuda. That's securityweekly.com/Barracuda. Welcome to Paul's Security Weekly. This is episode number 772, recorded right here in G-Unit Studios in Rhode Island on February 8th, 2023. I'd like to introduce my illustrious co-host for this evening. Mr. Sam Bound is here with us. Sam, welcome.
Well, hello. I'm glad to be here with you.
Mandy Logan joins us.
Hello, everybody.
And Josh isn't on OnlyFans. He's on a site called Older Fans, where it's just him telling you what part of his body hurts today and what minuscule task that he performed that caused it. Josh, welcome to the show.
Thank you. Yes. And don't worry, I have my vitamin I.
That's right.
Which for older people is ibuprofen.
That's
Trust
right.
me, I've got car ibuprofen, upstairs ibuprofen, downstairs ibuprofen.
Bedside ibuprofen. I have bedside Tums too as I get older. I get the heartburn.
Yeah, that's actually very true.
You have that too, don't you?
I do.
Security Weekly listeners can save $100 on their RSA Conference 2023 full conference pass. The RSA Conference will take place on April 24th through the 27th in San Francisco and also on demand. Visit securityweekly.com/RSAC 2023 and register with the discount code 53UCyber. Linux systems are a collection of free and open source software, some packaged by your distro, some built from source, and some coming from unknown sources. How do you verify that your upstream isn't polluted by bad actors? Joining us tonight is my good friend Hal Pomeranz to help us dig in and discuss some practical solutions. Hal, welcome to the show.
Hey, thank you, Paul. It's great to be back. I was trying to think, when was the last time I was on PSW? And I was thinking, wow, it was a really long time ago.
It was a while ago, too. And I asked you about your start at Bell Labs, which we probably talked about, years ago or whatever. You came on the show last. And just you have awesome stories from the days in Bell Labs. I mean, you started doing Unix stuff, at least in a professional capacity. So you were out of college 10 years before I was introduced to Linux for the first time.
Yeah, and I don't even consider myself one of the really old school people, because if you hang out at Unix with people like Cheswick and Bellavin and Thompson and Ritchie, you think, God, I'm just this young kid, right? I mean, they were doing this crap in the 1970s. I only touched a Unix machine in the 1980s, but that just seems like unimaginably long time ago.
Yeah. Well, it's interesting. Now we jokingly reference it because we reference it all the time. Ken Thompson's paper about supply chain attacks in it 84? I think he wrote it in 84. Was what we determined. 84 or 86, one of the two.
Yeah, long time ago. I mean, in any event. Yeah, and that was, and it was a really seminal paper. And also, by the way, just like a really cute little hack, a little compiler bug that recompiled itself when you bootstrap the new version. And I also think it's ironic. I mean, we're here talking about this during the week that there was yet another OpenSSH vulnerability. Because when I think about like supply chain kinds of attacks, I think about like the early 2000s with OpenSSH, where there were all these bugs in the libraries that OpenSSH was built on, OpenSSL and Kerberos and SKey and all that stuff, that actually led them to develop privilege separation and self-defense. So this has been going on for a really long time, and I think we're resensitized to it now since SolarWinds and all of the NPM attacks and things like that. But this is something that people have been banging the drum about for quite a while.
It's almost like we had to reach critical mass where the percentage of code you would actually write yourself has diminished to such a point where like 70% of your application is other people's code.
Yeah, right. I mean, you think about, deploying an app in the Linux space, or really almost any platform, but let's just talk Linux in particular. Like I was playing around with the latest version of Volatility in my lab, and like even to get started with that, you end up pip installing a whole bunch of Python packages just for basic functionality. And like I don't know where those packages came from.
Well, yeah, pip is like the Mos Eisley of packages, just like NPM. Right. NPM is yet a different version of Mos Eisley.
Yeah, and that's just increasingly common. Everybody's you can see further because you build on the shoulders of giants, but you can also get yourself deep into crap if you're building on the software of evil. So and that's just the way we do software development these days.
Right. Well, I don't know. In certain cases, like the kernel, for example, only because I've talked to people, the past 2 months about this particular problem, I have a higher degree of confidence that the developers that are working on the actual code for things like the kernel and in other projects, I trust that more than the folks who are packaging that up downstream, right? Because I mean, not too many of us are using a distroless flavor, distroless Linux, where you're pulling all these pieces yourself, right? We're relying on other links in the supply chain to get our software. It's those other links, Hal, that I don't trust as much as when they release a new kernel version. Like, I think they did a pretty good job with security.
Yeah, I mean, although, okay, so let's suppose you did the whole Linux from scratch thing and you downloaded your source from kernel.org and all that stuff. I mean, you're still then pulling in a bunch of userland packages from somewhere, even if it's from source. I mean, nobody's really scrutinizing the source repositories for this stuff very closely. So even if the package managers are doing the right thing with the best of intentions and high levels of security before they package and sign that, I'm not clear that their upstream, which is the source on GitHub or wherever, is necessarily that free from interference as well. So there's this whole big stream of events that need to happen before that package ends up getting apt installed into your Linux distro, and lots of places along the way where that can go bad, right?
Yeah, it might. So I know it's somewhat of like a religious war. I was conversing on Mastodon today about my flavor of Linux desktop distribution, but what drove me, so I was frustrated with Ubuntu. This is actually what led to us spending 2 months talking about software supply chain security, because I was frustrated with Ubuntu, is really what it boils down to. And so I was running Ubuntu 20.04, and I'm like, I need this piece of software. I'm like, okay, well, the official Ubuntu repo has an old, outdated package, if it has it at all. And so maybe I'll go to that software provider's Ubuntu repository, and that's hit or miss whether or not they're maintaining one or not. But then they also have to maintain the chain of trust for that particular repository as well. Then I was like, well, I can get this software in an app image, or I can get it on Flatpak, or I can get it on Snap. And sometimes I had like all 5 of those options. I'm like,
exactly.
I'm like, so now when I go update, I'm like, I need to update all my software. Like now I got to go to like 4 essentially different places to go do that.
Right. And you've got to, hold back the distro package from updating and basically downgrading the one that you got from the alternate stream. It's a mess. And then it gets messy. You're doing that for your personal laptop. Imagine trying to do that at enterprise scale or, in a cloud environment where you have, thousands of virtual instances spun up. It's a nightmare. So
I hate myself, but what you're saying is you're both advocating for a walled garden environment where somebody is centralizing this and managing it and securing it for you, such as, for example, Windows or Mac.
Not necessarily.
Well, we haven't gotten there yet.
Yeah, but Hal, back to your point, though, I think folks that manage thousands of Linux systems, right? Like I manage maybe a couple dozen or whatever. Like some are in production, some of my personal systems. But if you're managing thousands, you have your own. I've seen shops set up their own repo. So they take in the packages, but they manage their own repo. So that, in your sense, Josh, they become their own walled garden, essentially.
Okay, and that's valid. But seriously, other than that, you realize that, Hal, I'm sorry, but you two are absolutely advocating for Windows servers everywhere.
No.
No, you just did.
Even in the case where you're running, your own package management system, your own walled garden, if you want to call it that.
Yeah.
When the reality is, where did those packages come from? I agree that organizations are going to have their own, sort of canonical standard package set that's different from the main distribution, but those packages still have to come from somewhere, and they're still just as vulnerable to pollution as the Ubuntu repositories or Snap or whatever. So I think ultimately you're even being as careful as you possibly can, you're still going to have issues with malicious actors polluting upstream. And
they're going to get the compiler that compiles the compiler.
You see, you get Ken Thompson again.
That's right. He likes referencing that.
So no, seriously, and you're right. So this is a supply chain issue in all major operating systems. That you no longer have a monolithic operating system. Back in the day, it was effectively a monolith. You had a core group of people who, if you had a problem, you go, "Hey, Jimmy, what are you doing with that line? Blah blah blah." Right? Whatever. And now it's so fragmented that everything is a supply chain down to the operating system. Even are we talking the same language here?
Yeah, but I that's not a new problem, right? I think
exactly.
That, and so my take on this is, if you believe my hypothesis that there isn't much that you can do, sort of left of boom, you better be in a position where if you do have a supply chain issue, that you're on top of that right away, right? And to me, that argues a lot more for, architecting your systems in such a way that, the vulnerability doesn't get a lot of traction. And that was, if you think about it, that's exactly what OpenSSH did with privilege separation. They architected their environment so that when the next remote OpenSSL exploit happened, it didn't matter because you were talking to unprivileged process that was CH rooted in an empty directory. So one is, mitigation at the deployment level. And also I think mitigation at the network layer, right? If there is a successful exploit, that thing's going to try and phone home. Well, why are you letting your web servers phone home in the first place, right? Egress filtering is a thing.
Outside your boundary or outside your enclave, phone home. Yeah.
Right. So you can deploy your unknown third-party applications in such a way that you can mitigate these kinds of vulnerabilities before they get started. And also, I think it says a lot about monitoring, right? Like Paul, you and I were talking offline about the little snitch app on Macs. And Evil Socket actually has done OpenSnitch.
Yeah.
I discovered.
I just put that. I saw that, Hal, and I just put that on this laptop on the left. Yeah.
Yeah. So like you can get the Linux equivalent of that, but I mean, at an enterprise level, you're talking about network security monitoring and looking for this stuff, trying to phone home. So I expect supply chain's an interesting and relatively straightforward way for an attacker to have a big impact across a lot of systems. And SolarWinds definitely demonstrated that, right? And
Agreed.
So, and you can see people typo squatting on common NPM packages, right? So they're looking for people misspelling NPM packages and trying to inject malicious code that way. So I think we're at the beginning of a real red team focus on supply chain.
Yes.
Yeah, but
Sorry,
I think
agree more.
But I think to your point, Hal, it just kind of made me think of how we shouldn't ignore the right of boom, right? We should monitor our systems, our logs, our network connections. Like, we're not saying don't do that. What I'm saying is I think we can do a better job, I think it's kind of what you were alluding to, do a better job of being able to trust our upstream suppliers of software. I'll leave hardware out for now, but in this context, just software, right?
Okay.
I'm going to add on that he also said, and I agree with him. By the way, Hal, I was baiting you with that, and you know that.
No, I know.
And I agree with you 100%.
I've been insulted by better people than you, my friend.
I wasn't seriously trying. If you want me to really try, we'll talk. But anyway, no. No, seriously, I agree with you. Monitoring, architecting it so that even if, so that it's resilient, so that even if compromised, it can't do any damage or minimize damage. Absolutely agree with you. And then to Paul's point about trusting your upstreams, let's talk about that for a second. How can we trust our upstreams? What are the measures we can take to make our upstreams trustworthy or verify or validate our upstreams trustworthiness? Paul? Hal?
So, I mean, I'm seeing some good signs happening. I mean, you see Google handing out, two-factor authentication tokens to critical software repositories. I mean, you can see signs of people recognizing that these supply chain issues are real and trying to enforce good security practice on at least the critical infrastructure, shall we say. And that's being met with various, amounts of pushback. Like some people are just like, I'm out, I'm abandoning my project because I don't want to deal with the security stuff. But on the whole, I think, we're starting to see infrastructure providers trying to be the rising tide that lifts all boats there. I would like to believe that these very public supply chain attacks have gotten some of the major software providers and major distro providers to take a look at how they're packaging their software and how they can do that a little bit better. I mean, like, I don't think anybody, Ubuntu or Canonical, I should say, or Red Hat, IBM wants to become the next SolarWinds, right? Nobody wants to appear above the fold on the front page of the New York Times. So I would like to believe that these companies are at least doing a little bit to shore up their packaging. But ultimately,
to that point, I mean, they're making you pay for it now, right? Like on the server side, and I get it. I mean, Ubuntu Pro is essentially kind of following the model of Red Hat, right? In that you pay for a subscription, you get some really stable software, and you get updates for longer. And I think in that case, much like cloud computing, you're pushing the responsibility upstream. And especially like, I'm paying for this. Like, you should make sure these packages aren't tampered with.
Yeah, you should. That'd be good.
But if we trusted all of our suppliers, all security people could go home and retire.
Right.
Oh, God.
So, I mean, it takes a village, right? I mean, all this software comes from multiple sources, and then is packaged and retransmitted through multiple other layers. And each layer has to get it right. That's an exciting challenge.
Well, that was the whole thing with flat. I mean, to your point, like the whole thing with Flatpak. I'm like, well, what's in this Flatpak? I'm like, oh, whoever puts this together can basically run commands on them shell in this file, like right here. Like, that's bad.
Yeah, well, I mean, any package that you in a modern operating system is going to have pre and post installation commands that can trigger, right? There's going to be some sort of hook there for running arbitrary commands. So, it's not, that's just kind of the way things are these days.
Yeah, so you have to trust the packagers as well as the software that's packaging it, the people that are packaging it and writing it. It trickles all the way down.
Yeah, and I mean, this stuff, I mean, look at SolarWinds, right? I mean, that, the bad guys got in there, and admittedly, they were dwelling in that network for a year, so they had plenty of time. But they made a very subtle modification to incorporate that sunburst object into SolarWinds, right? It's like basically a one-line change in a build script that it injected an object in the middle of the build process. And I mean, you look at these build processes for enterprise software, and they are hellishly complicated. So the chances of somebody noticing that, even within the organization that's packaging the software, seems very, very small. So, that speaks a lot to configuration management and software version management control on the upstream side. But this is hard stuff. I'm encouraged by the fact that I'm actually starting to see, people requesting my services, not for doing IR, kind of right of boom, but I actually am probably going to engage fairly soon on let's just say a contract for a large software vendor to actually audit their build process proactively. So I think people are becoming conscious of this and at least trying to make it better. But it's big, ugly, and complicated.
Yeah, because there's a lot of responsibilities here, right? There's the responsibilities of upstream suppliers that are making the components that represent your libraries that you're including. There's your responsibility to put your own software together. Then I feel like there is some responsibility on the users and administrators to validate that. Whether it's a signature, a hash, an SBOM, whatever it is, we still have to do our due diligence and validate it and not just blindly trust.
Yeah, I mean, although, in some sense, the hashing and signature validation, at least from the operating system package perspective, that's built in, to apt, right, or whatever. But yeah, I mean, if you're building from source, absolutely. I was thinking about back in the, probably 90s, somebody broke into sendmail.org and dropped a bogus package in where the build script was backdoored. And the hash didn't match. I mean, there was a hash out there, or a signature out there on the site, I should say, that didn't match the corrupted package, but hundreds of people downloaded the bad archive before anybody thought to check the signature to see whether it was valid or not.
I mean, the good news there is 85% couldn't get it to build anyway, so.
Yeah, well, and the rest of them couldn't get SendMail working anyway to save their life. So, it was all good. No, but that one, the build script, the minute you ran the build script, it actually joined you up to a botnet. So that was a fun one.
Well, Hal, I'd like to hear what you're going to do in that audit. I mean, what can you do except notice outdated versions of things?
Well, I mean, so I think that the audit's going to be on several levels. One is just the security posture of the systems in their build environment, right? It's the classic story, right? You got to focus on the operating system and on the software stack, because if you've got this really locked down software stack, but the OS is wide open, then they're just going to come in through an OS vulnerability and attack you that way. So one is, just like making sure, they got their platform stuff locked down. And that's both, at the host level and the network level. But then it's going to be a matter of going through their, the actual software build environment and all those layers and understanding like where the gaps are, right? Like, is it possible for somebody to do a SolarWinds to you? Can somebody get in the middle of your build environment and make a small change to, say, inject an object file? You've got your software, the actual software you're building in something like Git, I would assume, so that you can have, historical view of who's submitting changes and what those changes are. But what about your build environment tools? Like everything around the creation and packaging of that software, are those tools also similarly monitored and audited and checked in with a retrospective history so that you can go back and audit that? And who has access to those tools? Like, so, and this gets into user roles and responsibilities and access, right? It's like, does everybody in development who can check in code to the main software project also have access to the build environment, or the limited release engineers who can do that stuff? So I think there's a lot of layers where you can look at a complex environment like that and provide, value and suggestions about how to do that better, right? And then once you've got...
I was just going to say, I think the most challenging thing in what you described, and having seen it build environments in my day as well, is that the purpose of a build environment is that people submit changes and you get a new build. And what we're trying to do is detect if someone put a change in that wasn't intended and we got a new build that wasn't the build we intended. And that's hard.
Right, for sure. And then how does that unintended change propagate through future versions and things like that? No, I mean, it's, hey, if this stuff was easy,
we all just sign our commits and everything is good, right?
Yeah, absolutely. Right. I mean, but is anybody really looking at those commits? I mean, do you have, people really, really looking at that code?
I have ChatGPT looking at it. Isn't that enough?
Yeah, right. Exactly. And so I think that there's, like, not to, telegraph my intentions or anything, but I think it'd be interesting in a lot of software, distributed software development environments like that, to with the permission of the organization to submit some, I won't say malicious, but some hinky, well, like Ken Thompson, right? Just like a little self-propagating virus that doesn't do anything, but like, can you get that through code review in that organization, right? Like, could I, as Wally, the junior developer, submit my first few commits, and then a little bit down the line start injecting some odd stuff.
How it's funny you say that. So we go back in time to when we interviewed Gary McGraw. I'm sure you probably met Gary once or twice in your travels, or familiar with his work anyhow, right? And he was talking about different types of software, bug versus a flaw. And he described a flaw as like a functional error. And he's like, I'll give you the most popular example. He's like, forgot to authenticate the user. I was like, oh, years later, I introduced that very same bug into my software.
Yeah.
Like,
right.
And it wasn't I forgot to authenticate. I mean, not necessarily that. It didn't matter what you entered for a password. Every value was accepted. And it turns out, like, unless you really sit down and think about what all those test cases should be, you'll often miss that bug entirely.
Right. Yes, absolutely. And that's not even an intentional, right? That's like a oops, my bad, right?
Well, no, it was intentional because I couldn't log in. So I had to disable authentication so I could log in. And then I forgot to go back and change it back, and I committed it upstream.
Yeah.
That happens.
Yeah. So, it's really, really interesting. Like, it's a really deep problem. And I think that people, right now what I'm hearing is a lot of, couldn't you just, whatever, right? And when I hear, couldn't you just come out of somebody's mouth, that is my clue that the person who's saying that doesn't fully understand how deep and complicated a problem this is, right? So, I'm on this learning adventure now, and I am, I know I'm going to start turning over rocks and find all this bad behavior. And I think that, as with any sort of complicated thing like this, all we can do is, incremental steps to make this better. But, we have to remember that the first job of these organizations is shipping software, right? So you have to come up with a way to make this kind of heightened security frictionless as possible for the developers. And, it's the usual security versus ease of use dichotomy.
Well, yeah, go back to our Linux example. Whether you're on the desktop or the server, your goal to be the most popular Linux distribution for either is, I want to package as much software as I can to make it as easy for the user and or administrator to install that software, right?
Right. I mean, when you hear people arguing about which distribution is best, they're not, the argument is never about, wow, I feel really secure with this distribution. It's like, this distribution has the stuff that I want to, whatever it is, game on Steam, or watch my cat videos, or, create content for Twitch or whatever it is, right? People want their desktop experience and their applications to be as frictionless as possible. So that's what you sell your distro on, right?
What do you think of Ubuntu Pro?
As little as possible. No, I mean, okay, so you're getting into my, kind of old school.
When we used to compile everything by hand.
Yeah, it's like, God, you stupid, kids, get off my lawn. Right?
Go get the source and compile it.
I remember when we had to compile our own kernels on RK05 disk packs, and there's so many good free distributions, whether it's whether you're a Red Hat person and you like Rocky Linux, or whether you're just like going to go with straight Debian, without all the sugar coating on top of it, or I mean, if you want the kind of delightful everything's good to go kind of distribution, I mean, there's all these Ubuntu spins like Linux Mint and things like that. I mean, so I don't, I hope none of these people are your sponsors, Paul, because I don't really see a need to pay for Linux.
I agree. I agree 100%.
Enterprise customers, I think, like that feeling of security that they get, having somebody to blame. But I tell those people, okay, I mean, that lets you sleep at night, but when the rubber meets the road and there really is a problem, do you honestly believe that enterprise license is going to somehow magically make your life better when there is a massive supply chain issue? And the answer is I don't really think so.
Well, I think it's an architecture. When I thought about Ubuntu Pro, I was like, well, that's interesting. Like, if I use Debian, I'd be in an upgrade cycle to a certain extent, probably based on my software requirements. Especially if I wanted newer software, I'd have to upgrade. I think what Ubuntu and Red Hat largely are promising is you can get your software and we'll take care of the updates so all your packages are integrated together. I think that's what you're paying for in those ecosystems. Maybe some extra security that they've done the validation of that. Hopefully they've done the validation of that package to go, it's not been tampered with, and give you a clean package. But then you go to a rolling release like Arch Linux, and the open and free project is doing that for you. That might be a little too bleeding edge for you.
Yeah, right. And even the free distros, have LTS cuts where they're like, we're gonna support this particular configuration for multiple years. So I don't know. All I'll say is if you've done the ROI and you think that that license pays for itself in your environment, then more power to you. The problem is, having done this as long as I have a prejudice towards doing it myself that maybe is misplaced. Yeah.
Well, I think I was talking to someone about developers too, but in this case, administrators, the skill level is one of the variables that you have to put into what chooses your architecture, right?
Sure. Yeah.
To be clear, Hal, it's a fetish, not a preference. Okay.
It's been really interesting. Obviously, you guys are aware I've been teaching Unix and Unix security for decades now, and it's been really interesting to watch that experiential curve change as my classes have gone on through the years. Like when I first started out, there wasn't a lot of clue out there, and I was teaching people who were relatively new and inexperienced to Unix, and then gradually, like through the .com era, that really skill level really ramped up, and I was talking to people who were at my level of expertise or above. And then the .com implosion happened, and a lot of people fled the industry, and the skill level dropped back down again. The DevOps thing has been weird. You've got people who are coming into managing systems from a software development background, and they don't have the history of systems administration necessarily, which has been interesting and challenging for them and for me.
I agree. I assume that you've also looked at developers like Docker files, and you're like, what?
Yeah, and it's really funny. You look at the history of Unix security, and you see similar kinds of vulnerabilities coming back over and over again. It's kind of like based on programmer generations, and it's because the new generation of developers hasn't been dragged through the same minefields that the previous generation has. They haven't learned those lessons at a gut level, right? And I was as guilty of this when in the late 80s and early 90s, when I was really sort of getting into Unix professionally. It was people like the people I got to know at Bell Labs who said, "Oh, foolish child, let us explain our wisdom that we have garnered.
These permissions matter."
Yeah,
a lot.
Yeah, and no, don't open files as a privileged process in a world writable directory, because these are all the things that can happen to you when you do things like that. So those lessons we're constantly learning and then forgetting, right? We're not good at passing along that institutional knowledge, and so we see vulnerabilities recurring, right?
Yeah. Yeah, like the Docker group thing that I have for my news story. Like, you can just spin up a Docker container and it's privilege escalation. Like, someone has a GitHub. It was posted like 4 years ago. It still works. Because the local user ends up in the Docker group and access to the Docker sock file, right? And I forget exactly why that's the case, but it ends up you can gain root just by spinning up a container.
Yeah, and this belief somehow that oh well, it's in a Docker container, so it's insulated from the rest of the environment. Nothing bad can happen with the software that's in the Docker container. I'm like, well, no, it's not really like a force field or anything. It's but people were the same way when virtualization first started getting big in Linux. And it's like, oh, well, it's in a virtual machine, so whatever happens in there, just happens in there and won't impact anything. It's like, well, no, not exactly. It's a brave new world, and there's a whole new group of folks who are getting involved at this who maybe haven't had some of these, I like to call them learning experiences.
Right. Yeah, I feel like we learned when we were like, oh, that's why you don't run a process as root. That's really bad.
Right. Yeah. Like why does all this software now run as unprivileged users? Right. Because like I grew up in the era when we ran everything as root. Right.
Mm-hmm.
And then we discovered all the reasons why it's bad to have, like fingerd running as root, and things like that, or sendmail running as root.
Right.
The problem is Chmod 777 works, and it always makes things better, right? At least in terms of getting your product out the door. It's only later do those kinds of choices come back to bite you in the butt.
It is a functional assistant. Yes. It helps you function. Doesn't help you secure.
And so, like I'm a big fan of security that's implemented, at the operating system level and below, right? So, like I'm still a big booster for SE Linux, although I know that's a dirty word for a lot of people. But from an application whitelisting, this is what your application is allowed to do and nothing else. I see real value in that. Some of these hypervisor-based security models that interdict bad behavior within the application. I think those are interesting because ultimately, the goal of the software developers is to ship their software, and so there needs to be a point of control at the operating system layer or below that enables you to rein in some of those destructive tendencies.
Have you, and when you've done a lot of Linux forensics, Hal, and when you start talking about hypervisor level, and then I go a step before that and go to the bootloader, like that's also software that we have to trust. But I also feel like it's software that we don't really want to interact with it unless we have to, and we just want to trust that it's there and it's working and secure.
Yeah, like nobody wants to go there, right? And of course, I mean, you can see where it's also like that bootloader security stuff is also a potential Trojan horse for vendor lock-in and things like that. So yeah. In the decentralized, sort of cloud-based environment that we're building, for most applications, that are built on top of infrastructure as a service stuff, that boot layer stuff doesn't matter. I mean, it's definitely important for the people who are running the infrastructure that your platform is deployed upon. But we're well past the days in Linux where most people anyway are running stuff on physical hardware, right? So that happily masks a lot of those secure boot issues. It's only weirdos like us, Paul, who have Linux laptops that worry about this.
It's very true. It's very true. But even at the server level, you still have to concern yourself with the kernel and also kernel drivers and kernel modules. Sure. And we talked about, Josh, you were saying at the top of the interview, like trusting Windows software. Microsoft has signed, I believe, I mean, don't quote me on this, it's like 30,000 drivers. Is it 30,000 drivers they've signed?
It's some ungodly
number. And we don't have a list. Like Microsoft doesn't release a list of like, hey, here's all the stuff I signed. But in the Linux kernel, do we have that kind of? Do you have to do it yourself to sign those modules? There's no walled garden of like, here are the modules that are signed, right?
I mean, there is, there's the whole taint checking thing in the Linux kernel, which is kind of a weak form of that. I mean, yeah, right. I mean, it's this happy, fun, open operating system, and people should be able to write code to support whatever they want. And to some extent, it's a double-edged sword, right? I mean, the benefit is like, you give me some random piece of hardware that you want to get working in Linux, and I'll just sit down and bang out a driver for it, and we can get that sucker going, right? There's a reason why Linux had better USB 3 support faster than either Mac OS or Windows, right? It's because, folks like Sage Sharp, like just sat down and wrote really kick-ass USB 3 drivers for Linux and shoved them into the kernel. So I get your point, right? But there's also
secure boot helps with that, but it still falls down on the individual, right? It's not an external third party that's saying this driver's good or bad. It's me saying, yes, I added this driver. I'm going to sign it with my own machine owner key, and it can load into my kernel.
Now, I mean, to be fair, though, there is a lot more scrutiny at the kernel level in Linux than anywhere else, right? I mean, you were talking earlier about the folks at kernel.org. I mean, if anybody's paying attention, right, those people are. And so I actually
they detected an attack. There was a group that purposely introduced a vulnerability and tried to push it in the kernel, and they caught it. I keep meaning to pull that story as a reference.
Yeah. I mean, but I can also remember back in 2012, there was a group of nation-state attackers who managed to pivot all the way into kernel.org from various other open source projects. So, but like I said, I trust the people who are building and maintaining the Linux kernel more than I'm trusting some, random userland software that I'm pulling into my operating system.
Agreed. What is kernel tainting?
So, it's a very simple mechanism to try and prevent, the random loadable kernel module rootkit from infecting your kernel. At least it'll raise a warning when an atypical driver gets mod loaded into your kernel. And it was created back in the day when LKM rootkits were popular. So this was late 90s, early 2000s kind of thing. We saw things like Phalanx 2 and things like that. And it's not a full on driver signing mechanism like Windows is implementing right now, but it is at least a simple checking for potentially malicious kernel modules. The problem is,
so it looks at the kernel system calls and kind of makes a decision and
there's a little bit of validation, but the problem is, and this is why I'm more attracted to kind of hypervisor level security. The problem is that it's a typical problem with the Unix and Linux environment, right? It's this all powerful root user, and once you achieve root level privilege, any security mechanism in the operating system can be disabled by the attacker, right? So you have, checking code in the kernel, or maybe you've installed your own, good kernel module that tries to resist the introduction of malicious kernel modules. Remember the old St. Michael tool? But the problem is,
eBPF, right? We talked about in OpenSwitch does this, right? It loads a module that hooks into eBPF to do process monitoring.
Yeah, and we're starting to see eBPF rootkits. Rootkits entirely implemented within eBPF because hey, it's an interpreter in the kernel. What could possibly go wrong? Right. And so that's the problem, right? It's once I get root on the system, there are any number of ways that I can subvert operating system level security controls, and that's just the security architecture for Unix, right? Even SE Linux, right? Once I'm root, I can start messing around with your SE Linux policy and start disabling that. And so again, this is why I'm more of a fan of stuff that's interdicting from outside of the operating system, so at the hypervisor level. But that's a brave new frontier, and there are people in that space, but we'll see.
That's interesting. So is it purposely implementing security in the hypervisor level? Because it dips a ring below the kernel, essentially.
Right. Yeah. I mean, so you break the operating system, there's still this thing below the operating system that's interdicting you. So back in the day, I was doing some technical advisory work for this outfit called Immutable Systems. They got bought out by VMware, and I'm not sure what happened to their technology, but they had a shim that sat between the guest operating system and the actual hypervisor, and they could interdict, process memory and file system network calls. And so, for example, loadable kernel module rootkit, it's going to need to hook the system call table. They could literally make that immutable. So the LKM would try and write to that, and they would go, "Oh no, sorry, you're not allowed to do that." But at the hypervisor level, where it couldn't be thwarted by something happening in the operating system, they could implement a firewall outside of the operating system, so they could control network activity. They could make portions of the file system read only outside of the operating system. So user, except when you're applying patches, is mostly read only. So you could say, hey, look, all of users read only. And so now when you went to deploy your Trojan SSH daemon, it didn't work because you couldn't overwrite the good one. So stuff like that is interesting. But it's also hard, to get right.
Right. Yeah, because you're talking about low-level code. It's
and you're talking about instrumenting the operating system from outside of the operating system, which is always, a little perilous.
For sure. What else can we do on our Linux systems, Hal, to be more resilient to these supply chain attacks that we talked about?
So I'm a big believer in monitoring. Randy Marchani and I have, spend a lot of money up front on security, but invest the bulk of your dollars on monitoring. So, we talked about things like OpenSnitch or, network monitoring at an enterprise level. And there's lots of good free tools out there. I mean, Security Onions, a load and go distribution for network security monitoring. It's got Zeek. It's got, all of these tools built into it, to snort and squeal. And
I also like OS Query too, and they included that in the Security Onion, and I really like that because it's cross-platform, gives you an inventory of all your software. I think that's a really great security mechanism.
Yeah, and there's also in an enterprise level, there's agent-based systems, and some of them are even free, like Velociraptor. There's a community edition. You can go out and you can deploy Velociraptor agents everywhere, and it gives you that SQL-like functionality for querying and getting inventory, but also hey, this new process showed up. Where else are we seeing that? Where did that come from? That kind of thing. I think eBPF is a whole new interesting frontier. I mean, we joked about some of the bad stuff you can do with it, but there's a lot of good that you can do with eBPF. If you want to see an example of a fully functional eBPF tool, I've been doing work with this outfit called SpiderBat, and they have a freemium thing. You can download their agent and run it on 5 systems for free just to kick the tires. But it's a graphical monitoring tool. It consumes eBPF data off of the nodes along with some other relevant information, and it builds this graph. And when something and it's learning, so it's historically watching the systems, and when things start going sideways, they can say, hey, we've seen this chain of events that would normally indicate bad behavior. Let us show you a trace of basically a process hierarchy. But unlike typical process hierarchy, they're also monitoring network connections, so they can say, look, this process hierarchy links to this one over here because they SSH'd between these two nodes.
And I think we've seen similar things on Windows, and that seems to be the thing that you're after as a defender is the process what files did it touch, where did it talk on the network, and if you can bring that into a system that helps you make sense of that and tells you about things that you need some attention, that's where it's at.
And has some heuristics on top, that they're like, this stuff is normal, this isn't. So anyway, check it out. I've had a lot of fun working with them, and we're trying to build some of my expert system into that product a little bit. So.
Oh, it's like the brain of Hal in my.
Yeah, I won't go that far, but it's like random flatulence from Hal that may or may not be useful. So
and you put it in a jar and you send it to him. I get it.
Yeah.
That's awesome. You have some of your courses. One of your courses is online. Your Linux Forensics, which is also a good starting point too, right?
Yeah, I mean, okay. Yeah. I taught for that other training organization.
Yes.
That shall remain nameless. But one of the things that because I'm like this hippie, peace, love, BSD kind of guy, I really wanted to be able to make my training courses available for free. Because for example, in Linux forensics field, there just isn't a lot of information out there. And the good people really need to know how to do forensics on Linux, because it's only becoming more important. So yeah, I have a 4-day class on Linux forensics. You can find it at archive.org. You can download not only the course book, but also the labs, which are in a VM that you download. Now, I also teach that course. I mean, I've been teaching it with, John Strand's folks over at Anti-Siphon, and privately as well. But there's just a lot of people who won't be able to attend live training, either just due to cost, schedule, or whatever. They still need that information. So I'm committed I have an SE Linux course out there as well, like a little 1-day SE Linux course. And I'm in the middle of finishing up a 2-day Linux command line skills class that I'm also going to be posting out there. So I'm committed to making all my courseware available under Creative Commons license. So you can take it and use it however you want, including in commercial environments, because I think it's more important that we get the information out there. And don't worry about me. I'm still doing fine. And people ask me to teach those classes because I'd like to think I provide value over and above just the basic courseware. So, but yeah, so I'm fully committed to sharing that courseware, and I'm continuously updating it and things like that. Speaking of eBPF, one of the things I'm hoping to wrangle into the next version of that Linux forensics courseware is some eBPF knowledge, both on the monitoring side, but also on the kind of forensics and incident response discovery side as well.
I dabbled with that. When you said, when we were chatting offline, it'd be really cool to have an eBPF filter that could look at all running processes and then tell me if there's new connections.
Right.
And I was like, wow, that sounds really hard to write. And I'm like, ChatGPT, write me an eBPF filter that does this. And it was like, oh, here's a hunk of C code, Paul. And so I tried to run that with some BPF tools, and I got segmentation faults, and then I had to move on. But
yeah,
like,
sure.
Fair enough.
But it's really, once you get into it, the eBPF stuff is not that terrible.
Yeah.
There's a reason why TCP dump was as popular as it was back in the day. But now we've got this instrumentation package that covers not just, the network layer, but basically all of the operating system. And that's interesting and scary. And, there's a huge attack surface there that we need to deal with, and we will be dealing with for the next decade. But in the meantime, it also provides some really interesting opportunities for visibility that we didn't really have before.
How in the Linux command line, Hal? You've been doing command line stuff in Unix for Linux for a long time. You're never done learning and discovering new things. Is that even still true to this day for you as well?
Oh yeah, totally. So, like on Mastodon, I've gotten back to our command line kung fu roots, and I'm doing these daily command line challenges, and I am am constantly learning stuff
from other users, right? Because they'll see it and they'll be, how about this? And you're like, oh,
how about this?
Yeah,
right?
I've never seen it before.
Yeah. And I fully admit there are times when I propose challenges and I'm not exactly sure what the answer is going to be, and I'm waiting for somebody smarter than me to come in with a really good answer. So there's all, like, again, like I'm this old fogey kind of Unix guy, and I learned Unix command line stuff in an era when we didn't have some of these nice features that are part of the GNU user space.
Right. We had sed and awk and grep.
Exactly. Right. And sort and unique and you liked it, right? and so like, for example, grep-c to count matching lines. I'm like, oh yeah, like that's POSIX. I remember that now. Right. But like when I started in the mid 1980s with Unix, let me tell you, grep did not have a -c flag.
Correct.
Right.
Yeah.
And so you would always grep and pipe to sort, pipe to unique -c or whatever. Right. But now you can do it, like in one command. So stuff like that. I mean, there's always new stuff to learn. Better ways, more efficient ways of doing stuff. Although, if you're doing it on the command line, efficiency is not your number one goal anyway.
No, you want it to work.
Right. You just want to get through today's problem today.
Without writing up Python or whatever script.
Right, exactly. So, and yet I still get people, like some of these challenges for daily challenges I presented, people are writing in with like Ruby and Python and Perl. And I'm like, no. The rules are you got to do it with, basic Linux command line stuff. You're not allowed to do anything more than sed and awk, which, I mean, admittedly are pretty powerful programming languages. Yeah. But, I mean, that's been fun. And I'm that's what gets me out of bed. I mean, if you're not learning new stuff on the job, it's maybe time to get a different job. I mean, that's always been sort of my attitude. I realize not everybody is like that, but for me, I want to constantly be challenged, to be extending my knowledge and things like that.
I think that's part of the fun with Linux and Unix. I mean, today Linux, right, is you're never done learning. There's always new commands, tools, techniques, ways to do things, new things you have to analyze, and that's what gets me out of bed in the day. I mean, it's why I run Linux on my systems, because actually I want to run into an issue where something doesn't work, and I want to try and fix it. Like that's part of the fun.
Right. I mean, my friend Jim says experience is what you get when you don't get what you want. Right.
Yes. Exactly.
I mean, that to me is fun. Yeah. I mean, not to be having that problem when I'm in the middle of trying to investigate an incident, maybe, but
right.
In
when
general,
you realize Zoom won't screen share because you have Wayland, because you updated your display manager. Yeah. Yes, why, you know how to fix it most of the time, but you're like, just not now.
Not now. Yeah. That's why you have the emergency Windows machine.
That's exactly what I do.
I've really got to get on this. I got to really get on this conference call. I'll worry about the Linux stuff later. Just let me fire
my God.
Zoom on.
Hal and I just admitted that both of us have been using Unix and Linux for a long time, and we both have emergency Windows machines.
Well, okay. I mean, because the issue has never been operating system.
No, it's an application.
Yeah, right. People don't give a crap about what operating system they're running. If Microsoft Office and Teams and Zoom and all these other enterprise applications ran natively on Linux with the same functionality that they had on Windows, people wouldn't care, right? I could give everybody a Chromebook and they'd all be happy as clams because it's their applications that they care about, not their operating system. I mean, to some extent, yes, they like, the windowing environment that they're in. Like, Danielle, who's been, she's a graphic designer and she's been using Macs since Macs existed, right? She's addicted to that window interface, the whole Darwin thing. So she would never change because of that. She's locked in to that look and feel. But if I could emulate that on a Linux box and let her run the Adobe Creative Suite on a Linux box, she wouldn't care. I mean, before me, she'd never even opened up a terminal window on her Mac. I opened up a terminal window on her Mac to do some troubleshooting. She's like, "What the hell is that?"
Yeah,
and I'm like, "Terminal window, honey." It's like, what is that? It's the actual operating system, the stuff that Apple doesn't want you to see.
Right.
It's become a running gag in my household. Like they open up a Mac and they see a terminal window and they're like, oh, Hal's been on this machine.
The hacker's been here.
Exactly.
And Adobe Creative Suite is one of those things that just doesn't run on Linux. I mean, they just don't port it to Linux.
Yeah.
There's open source.
For a while there, it didn't run on Windows. Like the only place you could get it was on a Mac. But now, actually, the Windows version is, I think, probably ahead of the Mac version, which is kind of sad. So.
Awesome. Well, Hal, when are you teaching your next course?
So I've got that Linux command line skills class. I'm going to be doing that at the Anti-Siphon Virtual Summit that's coming up at the beginning of March.
Okay.
And then I'm really excited. For the first time since COVID, I'm actually getting to go back to Australia. So the first couple of weeks in April, I'll be in Australia teaching Linux forensics.
Nice.
So that's really, I'm really looking forward to getting back down there, seeing everybody that I haven't seen in years. I'm not looking forward to the flight.
That's a long flight.
But
multiple flights, I'm sure.
Yeah, well, I'm on the East Coast, so it's Orlando to San Francisco, and then that long haul from San Francisco to Australia.
How much does it cost to attend your Linux command line class in the beginning of March? Is that the one you're teaching, command line?
Yeah, so I'm basically $500.
Okay,
rounding numbers, but basically $500.
$500 for 2 days.
2 days, yeah.
That's a bargain. Yeah, that's a bargain.
Yeah, well, it's a bargain compared to that other training organization.
Yeah, no, agree there, but also a bargain for can you take it if you've never seen a Linux command line, or should you have some background?
No, I mean, I actually start from zero. I mean, it's like, so if you've never done it, I think, it gets pretty deep pretty quick. But no, you can take it if you've basically never been on the command line. And
if you've got a lot of experience, I also recommend that you take it based on a previous discussion we just had. Like, you're going to learn something new. Like I promise you.
So the first time I taught the class, I had somebody come in and they're like, I don't know why I'm here. I know all this
One
stuff
of those.
already.
You've seen a million of those students. Yeah.
And I'm like, cool. Well, tell you what, here are all of the lab exercises we're going to do. And at the end of them, there's a bunch of lab exercises that I consider stumper questions. So here's what I want you to do. You can, when you get bored with what I'm teaching in class, just work on some of the stumper questions and, let me know how that goes for you. And pretty quickly, I saw them kind of tune out at first, and they were like working on the stumper questions. And then gradually more and more, I realized that they were kind of listening to what I was saying in class, because it penetrated to them that I was actually teaching them some stuff that maybe they didn't know. And that's the thing, like what we were talking about, like there's always something new to learn. Like I've been doing Unix for almost coming up on 40 years, Paul.
Wow.
Because I started doing Unix admin as an undergrad in 1985.
Yep.
And so, and I'm still learning stuff, right? And what's rewarding to me is when I have people who, come in and say, I've had 10, 15, 20 years of Unix experience, and I still learn stuff from this class, right? And I'm thinking, that's what I'm going for, right?
Right.
So, because nobody knows everything, right? And I learn stuff from my students all the time.
Yeah.
They learn stuff from me. I think that's a good trade.
It's awesome. Hal, thank you so much for appearing on Paul Security Weekly. It was good catching up with you.
Yeah, man. Good to see you. Let's not wait 5 years to do this again.
Let's do it again soon. I agree. Okay. Coming up next is the security news. Stay tuned.